Chapter 8, Unit 3. Let's talk about reporting the results of a statistical test. A result is said to be significant or statistically significant if it is very unlikely to occur when the null hypothesis is true. In this case, the result is sufficient to reject the null hypothesis. A treatment has a significant effect if the decision from the hypothesis test is to reject the null. So here's our example. Wearing a red shirt had a significant effect on the size of the tips left by male customers. Z is equal to 2.4. The probability is less than 0.05. If the test is significant, meaning the sample data is in the critical region, then we use the less than symbol. APA style does not use a leading zero in a probability value. So when you're talking about a p-value, or alpha level, you would use 0.05 instead of 0.05. So you would do this for all p-values. Okay, let's look at the reverse of that. The red shirt did not have a significant effect on the size of the tips left by male customers. Z is equal to 0.75. Probability is greater than 0.05. If the test is not significant, we use the greater than symbol. If a computer produced the exact p-value, then we would report it as 4 decimals. For example, we would say z equals 0.75, p is equal to 0.0164. Since p equals 0.0164 is less than 0.05, which is our chosen alpha value, then you know that the test was significant and that the result in the decision is to reject the null hypothesis. If you're using a two-tailed test, you don't need to include that in the conclusion sentence because it is always assumed. However, if you use a one-tailed test, you must include that information in the conclusion sentence. So here's an example. Wearing a red shirt had a significant effect on the size of the tips left by male customers. Z equals 2.5. Probability is less than 0.05, one tail. Let's look at factors that influence a hypothesis test. First off, if the z-score is large enough to be in the critical region, then we know that we reject the null hypothesis and we conclude there is a significant difference. And we know the z-score equation and we know the standard error equation. So one factor that influences the size of the z-score is the difference between the sample mean and the hypothesized population mean, which is the numerator of a z-score calculation. So a big mean difference is noticeably different from the untreated population and usually produces a significant treatment effect. So if the difference between M and mu is really large, then you can see Z will be large. Okay? Another factor that influences the size of the z-score is the standard error. And we know that standard error is influenced by standard deviation and N. So generally, increasing the standard deviation produces a larger standard error, which in turn produces a smaller z-score. So the larger the variability, the harder it is to get a significant treatment effect. The smaller the variability, the easier it is to get a significant treatment effect. So the larger the sample size produces a smaller error and a larger z-score. And again, larger z-score is what we want in order to reject the null. A smaller sample size produces a larger standard error, which produces a smaller z-score. So all of these have an effect on the z-score, which has an effect on whether we reject the null or not. Let's look at assumptions for hypothesis tests with z-scores. First off, random sampling. This means that for your experiment, you need to have subjects that are randomly selected. And we do this because the sample must be representative of the population, and random sampling helps with that. The second thing, we need independent observations, or what statisticians call I/O. Values in the sample must be independent of each other. The occurrence of the first event has no effect on the probability of the second event. You can't have the same person in group 1 and group 2. You can't have related people in different groups. So here's an example. A survey about which TV shows you watch. If you and your sister are both surveyed, the results would be skewed because most likely you're both watching the same shows in the same house. Okay, the third assumption is normality. Assume that the distribution of sample means is always normal. We have to have this assumption because if we want to use our z-tables, we have to use those with normal data. And here's a fourth assumption. It's not really talked about a whole lot. Normally the first three are the ones that you would list, but it is just kind of assumed that the standard deviation for the unknown population after treatment is the same as the population as it was before treatment. All right, so here's learning check problem 1. A research report includes a statement z equals 1.18, p is greater than 0.05. So what happened? Well, the obtained sample mean was very likely if the null hypothesis is true and the test failed to reject H sub O. Because you failed to reject because the probability is greater than 0.05, then you're in the body. You're in there with everybody else, the other 95% of the people. All right, learning check problem 2. A researcher uses a hypothesis to evaluate the null hypothesis, the mean is equal to 90. Which combination of factors is most likely to result in rejecting the null? So let's think about this. A bigger mean difference, but the difference between m and mu means that the higher z-score. So a mean of 100 is definitely more different than a mean of 95 when you're comparing it to the population mean of 90. So your answer is going to be either C or D. And then what you want to talk about is variability, the standard deviation. A smaller variability means a higher z-score, which means more likely to reject the null, more likely to be extreme. So smaller variability means higher z-score, so you choose the smaller standard deviation. So your answer would be C. Learning check problem 3. What assumptions are required for a z-score hypothesis test? The scores are obtained by random sampling. The scores in the sample are independent observations. The distribution of sample means is normal. All of the above would be the answer.